Hi, in this video, I will be showing you problem number 47 of chapter 11 and section 2. Determine whether the series is convergent or divergent by expressing Sn as a telescoping sum. If it is convergent, find its sum, sigma, n varying from 1 through infinity, e to the exponent 7 over n minus e to the exponent 7 over n plus 1. So the series can be written as sigma n varying from 1 through infinity an. So normally this term here corresponds to the nth term, sigma n varying from 1 through infinity an. Now as the problem says, use the telescoping sum method, and then Sn stands for the partial sum. So we will write down what the partial sum is, which is sum to n terms of the series, is a1 plus a2 etc. up to a sub n, which in short can be written as sigma ai, I varying from 1 to n. So this is an, which is e to the 7 over n minus e to the 7 over n plus 1, where the sub is n. If the sum is n, the exponents involve n. If the sub is I, the exponents will involve I. So this can be written as I varying from 1 through n, a sub I. So I have to take this expression and change the n to I. So it is e to the 7 over I minus e to the 7 over I plus 1. So now we are going to plug in I equal to 1 and then I equal to 2, I equal to 3, and successively up to I equal to n, and we are going to add all the terms in order to get the partial sum. So Sn is actually a sub 1, so I is replaced by 1 here. So it is e to the 7 over 1 minus e to the 7 over I plus 1. I equal to 1, so it's 1 plus 1, 2. Then now we will plug in I equal to 2. So it is 7 over I equal to 2. Then 7 over I plus 1. So it is 2 plus 1, 3. So then we'll plug in I equal to 3. So 7 over 3 minus e to the 7 over 4. So it goes like that, and then up to the nth term, e to the 7 over n minus e to the 7 over n plus 1. That will be our nth term. If you notice here, all the in-between terms, so e to the 7 over 2 with the negative sign, e to the 7 over 2 with the positive sign, these two cancel out. Then you cancel out e to the negative e to the 7 over 3 with the positive e to the 7 over 3. Same way, e to the 7 over 4 gets cancelled with the next term, e to the 7 over 4. So ultimately all the in-between terms are going to cancel out except the first member of the first term and the last member of the last term. So these two are going to remain. The rest of them are all going to cancel out. Okay? So we will have Sn equal to e to the 7 over 1 minus e to the 7 over n plus 1. Now the limit of the partial sum is the actual sum of the series, e to the 7 over 1 minus e to the 7 over infinity, n equal to infinity, so that will become 0, e to the 7 over 1 minus e to the 7 over 0. If you want to write one more step here, you can write the limit as n approaches infinity, e to the 7 minus e to the 7 over n plus 1. Because the denominator becomes very large, 7 over infinity will become 0. So it is e to the 7 minus e to the 0, which is e to the 7 minus 1, which is a definite limit. Okay, so because it's a definite limit, the partial sum converges to a definite limit. Therefore, the given series converges, and it converges to wherever the partial sum approaches, which is e to the 7 minus 1. Thus, sigma n varying from 1 through infinity, e to the 7 over n minus e to the 7 over n plus 1 converges, and it converges to the value e to the 7 minus 1. Hope this video helps.